Hey everyone, it's Mr. Canfield. Today we're looking at chapter 33, straight line motion. And this is revisited because we did derivatives with motion. Now we're going to do integrals with motion. That's the long and short of it. So I just want to remind you of a couple of things. We knew that if we had position, and position sometimes would be called S, sometimes it'd be called X, sometimes you could call it P, whatever you want to call it. So if we had, even if we had vertical position, we could call vertical position Y, right? So if we had Y of t, if that's position, then if Y prime of t, we would call that velocity, right? So the derivative of position is velocity. And Y double prime of t, we can call that V prime, or we can call that acceleration. So if you are in physics or have taken physics, this is a very useful and very straightforward, you even have, it's a concept that you've spent a long time with, theoretically. In this class, we don't deal with good units, we deal with imperial units. So instead of dealing with metric like meters and meters per second, we deal with, position would be in feet or inches or something like that. Velocity is going to be in feet per second. And these can change. Like it could be, instead of feet, it could be miles. And instead of feet per second, it could be feet per hour. But it's distance per time. And it's weird, but it's the reason it's feet per second squared is it's feet per second as it changes per second. So it's feet per second per second. And it turns out that as we go down the line, each of these, it becomes more and more, time goes up in third power, fourth power, fifth power, etc. But we basically go here, and that's where we stop. So for this course, okay, it's just a little bit of a reminder about some of our basic physics premises. All right, so it says, yeah, there we go. I'm not tired. Number one says, find V of t if A of t is equal to 4t minus 6 and V of 0 is equal to 3. I almost said V naught. If you're big on physics, a lot of times we'll say 0 seconds is our initial, and we could label that V with a little sub-zero under it. But so the big deal here is what we've done before is like, hey, if you know your velocity, take the derivative of it and find your acceleration. Well, now we're starting with our acceleration, and we're going to go find our velocity. So all we have to do is take the integral here with respect to time, with respect to t. So over here, let me get a thinner marker. Oh yeah, this has 2. Woo. So let's do integral dt, integral dt. If we do that, on the left-hand side, we'll get velocity. And on the right-hand side, we'll get, whatever this is. So, this is a really straightforward integral. It's not even substitution. There's nothing fancy. It's just, so 4t, that turns into 4t squared over 2, right? That turns into minus 6t, and then this turns into a plus c. So if we take the integral of acceleration, we'll get velocity. The integral of velocity, so integral of acceleration will get us velocity. Integral of velocity will get us position. And just remember that when we take the integral and we're doing a an indefinite integral without bounds on it, we have that plus c on the end. But we know v of 0 is equal to 3, and they're going to give us something like this usually to figure this out. Oh, so v of 0, that means when we plug in 0 for t, oh yeah, by the way, 4 over 2 is just 2. When we plug in 0, we get 3. Oh wait, 0, 0, so c is equal to 3. I'm trying to give you like the overly thought out explanation to this. So there are certain steps that I am not skipping and so on and so forth. All right. Question 2 and question 3 are literally the same question as number 1. So feel free to skip to question 4. I am going to continue. Question 2. This time in green. All right. So this time we're trying to find v of t, but now we know that a of t is equal to sine t plus 2t. And we know that v of 0 is 5. Okay. So same kind of thing. We can take the integral of both sides. And we'll get v of t. Oh, I did not talk about, I'll talk about that this time. And let's see, the antiderivative of sine is cosine, right? Let's think about that. What's the derivative of this? Negative sine. Oop, so it's not cosine. Because the derivative of this needs to be that. So if I throw a negative on it, now the derivative of this is that. Cool. 2t turns into 2t squared divided by 2, so it's just t squared. So let's talk about the plus c. Remember, you could have plus c on this side and plus c on this side, but we only need to have a single plus c. It's kind of the idea that if there's a bunch of, there's a plus c over here and a plus c over here, we can kind of put them all together and call them one singular random constant or arbitrary constant. We don't know what it is, but it's something. So we don't need it on both sides, we just need it on one side. And conventionally, we put it over here. All right, so it says v of 0 is 5. So we know that when we plug 0 in, we get 5. Oh, does everything just cancel out? Oh no, be careful. Cosine of 0 is 1, so this is actually negative 1 plus c. So we'll add the 1 to both sides and get c is 6. So our velocity this time is equal to negative cosine t plus t squared plus 6. All right. And I'll do the last one. Number 3. So 3 says a of t is equal to e to the t plus uno. We know that v naught is negative 1. All right. So in this one, again, if we take the integral of both sides, the integral of acceleration is velocity. And over here, the integral of e to the t is e to the t, like it doesn't change. That changes to a t. Then we have a plus c. So this is honestly, a lot of times I won't even show that I'm doing an integral. I think that's sloppy. I think I should have said this. But I'm not going to hold it against you if you don't do that. I think that it's kind of a dangerous thing to do, to not write stuff out. All right, v of 0 is negative 1. So that means we get negative 1 at the end. E to 0 plus c. Oh, e to the 0 is 1, right? So when we subtract the 1 from both sides, we get negative 2 is equal to c. So velocity is equal to a to the c plus c minus 2. Okay, so very formulaic to do these, but as you know, a lot of times AP questions are not formulaic. So let's move on and see what else there is for us. Let's define two terms. Displacement, the difference in distance between where you start and where you stop. This is a really, really good diagram for us. So I'll just make it bigger. So displacement is, we're really just saying, like, we're on some number line here and we start here, we go, oh wait, and we stop here. Right? So this right here is called displacement. Distance is not displacement. Distance is going to be, well, first we traveled all the way here, and then we traveled all this much. So I actually need more paper. So then we traveled, hopefully you kind of get the idea what I'm trying to talk about here. So we traveled this much, so then I would need to, so the distance we traveled was actually that much. And that's like saying, like, if I walk to the store and walk home, in one sense we could say I went nowhere, because I ended up where I started. My displacement is 0. In the end, I'm displaced 0 from where I started. But my legs will be tired because I did travel. The distance I traveled was whatever it is to the store plus whatever it is home. All right. So displacement, if you want to know where you end up, you just take the integral of velocity. But if you want to know the total distance you travel, you want to take the absolute value before you take the integral. And the reason why is, like, you could say, oh, I'm going positive 5 miles per hour, then I'm going negative 2 miles per hour, then I'm going positive 8 miles per hour, then I'm going negative 3 miles per hour. If we're trying to find out, how much do all those distances add up to, we want to make sure that even when we're getting closer back to home, that we're still adding that on. And so doing absolute value fixes that, solves that for us. So the particle moves along a line with velocity that, find the displacement on 1 to 7. You literally do not need to do these by hand. I'm going to leave this up to you if you do or not. I care about the idea here that if we go from 1 to 7 and we integrate velocity, this will give us, start to finish, how far away you are from your start. So, like, take this integral and you'll know how far you went, like how far you displaced yourself. I just use the words. So I'm gonna grab my calculator. And let's see. Integral from 1 to 7. T. So I'm going to use X's on my calculator. But if you use T, just make sure that you know, the D whatever at the end, as long as it matches, you're fine. Okay. So I'm just typing this integral into my calculator, and I'm getting it. I got 6. So this means that from time equals 1 to 7, whatever kind of pathway we're traveling, if we just looked at it on a number line, this right here, this, if we just looked at it on the number line, this is 6. That's what displacement is. So if we want the distance traveled on 1 to 7, there's a few ways to do this. One way is to graph it and find out where it's negative, and then the negative version of it, you'll split it up into several integrals kind of thing. And another way is to literally throw absolute value bars on this. And this will give us the answer. So I'm just going to go back into my calculator and throw absolute value bars on it. Absolute value bars. That's in the, it's in the same, it's in the math area, but it's under num in the second column. So think for me. We got 6 for the displacement. The distance should be more. So if I did this right, I should get more. I got 15. And there's a bunch of decimals and stuff after, but it was a whole mess of zeros, and then the decimals started showing up. So I think it's rounding error on the calculator's part. All right. Oh, this time it wants us to use, all right. So it says, a particle moves along a straight line with acceleration. And we know v of 0 is equal to negative 18. And we want t equals 0 to 16. We want to find displacement and distance. So the thing is, we need to find not v, but we need to find s, or or position. So our first thing that we need to do is we need to take the integral of acceleration to find velocity. So if I take the integral of, remember, this is t to the 1/2, right? So we add 1 to the exponent. Then we divide by our new exponent. And we know that v of 0 is negative 18. So if I plug in 0 here, I get negative 18. And that's going to be 0. And so c is going to be negative 18. So this is very typical. They do, a lot of times we'll start with acceleration. They'll give us some kind of initial condition, and they'll make us solve. So then we got 2/3 t to the 3/2 minus 18. This is our velocity. So we want to find, well, let's do displacement first, because displacement is easier. And we want from 0 to 16 seconds, or whatever the time unit is. So if we this is it, right? Literally just take that integral, drop it in your calculator. That is displacement. And then if we want to find distance, then we're going to have to find out. Sometimes this is positive, sometimes this is negative. So I'm going to set this equal to 0 to figure out when that happens. So 2/3 t to the 3/2 minus 18 equals 0. Find out when it changes signs from positive to negative. So I'll add 18 over here, and then we're going to have to get rid of the 2/3 somehow. So remember, to get rid of a fraction, you just multiply by the reciprocal. So 18 times 3/2, well, I'll divide by 2 first and get 9, then times 3 and get 27. So I got t to the 3/2 is equal to 27. And remember that to get rid of an exponent that is a fraction, you can exponentiate. No, that's the wrong word. We can take both, that's a different thing. Take both sides to the reciprocal power. So to the 2/3, to the 2/3. So on the left-hand side, we have t. On the right-hand side, we have, so to the 2/3, remember, that is our power. That is our root. So third root of 27 is 3. Then take that to the second power is 9. So at t equals 9, we have a transition from positive to negative, or vice versa. So what I'm going to do is I know that from 0 to 9, we're going to have one of them. And then from 9 to 16, we're going to have something else. So in this case, that means, let's see, it's either going to be the original, the 2/3 t to the 3/2 minus 18, or it's going to be the exact opposite, right? Because that's how absolute value works. It's either going to be this, or it's going to be opposite signs on everything. So let's think about from 0 to 9. If we try plugging in something from 0 to 9 here, like if I plugged in 0, I get a negative. 9 is where we get 0, and then over 9, that's where we're going to start getting positives. So I know that from 0 to 9, I'm going to have the negative version of this. And then from 9 to 16, we're going to have the plain version of it. And the cool thing about this is if I made a mistake, I can just, like, what's going to happen is if I'm backwards on this, I'll get a negative answer. And so I can just know that my answer is going to be the exact opposite of that. Okay. So I'm trying to think if there's anything else I need to explain on this. I feel like I'm being a little bit brief, but then we can go to our calculator and we can type it in. And if I want to like kind of make sure that I'm doing it right, I can actually type in the absolute value version too and see if it works. So I'm actually going to do the absolute value version first. So 97.200, 97.2. Oh. It's probably some fraction. That must be why it's 0.2. All right. Yes, that makes perfect sense because it's going to go up from the 3/2 power to the 5/2 power. So then we'll be dividing by 5, and it's going to be fifths. So sorry, I can't pause my video here. I'm going to blame iPhone on that, not my ignorance on how to pause my iPhone video. So we'd have to do two separate integrals here, the one from 0 to 9 and the one from 9 to 16. I did the wrong thing earlier. But I just confirmed that I broke it up correctly. So I got 179.467 for my answer here. Or 466. Hold on. Hey everyone, it's Mr. Canfield again. Gonna do question 7 correctly. Started doing it the wrong way. I started trying to take the derivative here. It says find the distance. So subway train accelerates as it leaves one station and then decelerates as it approaches another station. Following table measures the velocity v in miles per hour at 5-second time intervals. Find the distance the train travels every 5 seconds and complete the table. So the thing is, if we know velocity, right? Well, guys, velocity is the derivative of distance. So if I take the integral of this table, then we'll have our distance. Oh wait, integral. When we have a table and we want to do an integral, we do a Riemann sum. So we could, for this first one, we could go, oh, well, I know that, here, let me just draw it out. You know, we got all these little dots and we got who knows what it is. But we're able to go, oh, make a rectangle, make a rectangle, make a rectangle, make a rectangle. So with these rectangles, what's the base on each of them? It's 5 seconds, right? So we could say our base is 5 seconds, and our height is going to be whatever the y values are. The only thing to keep in mind is that when we go from 0 to 15, it doesn't tell me if I need to use a left, a right, a midpoint, or a trapezoidal sum. I'm just going to use a left hand Riemann sum. So my first one, the height is 0. So 0 times 5 is 0. But our second one, our height is 15, and our base is 5. But the one thing we got to make sure we talk about, 5 seconds versus miles per hour. We don't want to mix our units. We want to make sure that they're lined up. So I'm going to convert 5 seconds, because we use this one over and over and over again, into hours. We know that 5 seconds, all we need to do is multiply it and cancel out seconds, and then end up with hours. So I know in 1 minute there's 60 seconds, and then in 1 hour there's 60 minutes. It's called dimensional analysis. Cancel, 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 cancel. So if I do 5 divided by 3600, that's 1 over 720. Okay, so 5 seconds is 1/720th of an hour, and that is going to be the base of all of our rectangles. So remember that when we do Riemann sums, we're able to add a whole bunch of y values together and then at the end divide by divide, like, and then at the end multiply by our base. So if the part A is actually the longer part here. Part B, find the total distance between subway stops. All we need to do is add all these velocities together and then multiply by 720. Because that would just be our approximation of the integral. So it'd be 1 over 720 times 0 plus 15 plus 33 plus 42 plus 44 plus 44 plus 44 plus 44 plus 43 plus 34 plus 28 plus 8. And I'm stopping it. Remember, I'm doing a left-hand Riemann sum, so I don't include the far right tail. And if I was doing a right-hand Riemann sum, I wouldn't include the left-hand tail. So if I wanted to find the total distance traveled, then we could go through and do them individually. But this will be the total distance between the stops. And at some point here, we should get... Nope, brain broke, nothing. Okay. So I'm leaving A out because I don't feel like doing it. It's basically like you could do this little formula on each individual one and know how far it goes in that 5-second interval. But yeah, I'll have to splice these videos together. All right. Hope this helped. Bye.